Hi, this is going to be an in-depth look at how ThrowRock was programmed. I'm predicting this might have to be split into multiple parts because there would be a lot to cover if I wanted to go into depth with it, and I kind of do. So basic overview. ThrowRock is written in the C programming language using OpenGL for graphics, and it makes use of a code framework that I've been working on for probably over a decade by now. I forget exactly when I started the thing, but basically, I had done a bunch of ad hoc game programming over the years, and for every new game project, I would just start with, totally blank slate, copy over, basic window setup, OpenGL context stuff from the previous project and improve upon it. And I decided at some point, you know what? This is knowledge that I could encode into a fully reusable set of libraries and just use those for each new game. Then, I'd have a more capable starting point than just ad hoc copying code over from each project. So I had a lot of pre-existing stuff that I could build on top of going into this project. But anyway, basics of the C programming language. Okay, let's start with level of knowledge, I'm assuming, for the audience of this video. This is kind of targeted toward people who have some programming experience, maybe even some game programming experience, or not, but possibly not necessarily in C or with OpenGL directly. Like if you've done a little test project in Unity or something like that, or, written a few Python scripts, whatever. If you can just follow what code looks like, then I'm going to try and make this reasonably accessible, and go over the necessary details for that. So anyway, yeah, I had this existing framework of code that I've been using for quite a long time. It's fairly mature. I haven't released a whole lot of things with it to the public, but that's just because I haven't released a whole lot of things to the public in the last however long. This was the first game in a while. But anyway, I had a very good starting point. This is going to be kind of an exercise in picking apart what is part of that framework, which I call STEM. What's part of a system API, and what is new code that is written for ThrowRock. And additionally to that, what's just copy-pasted from Foresight Fight, because there's still some of that going on. When I start a new game project, there's some amount of knowledge that hasn't actually made it into the core framework. It still has to just be shuffled over manually. So that's fine. We'll see a bunch of vestigial stuff in here that's not quite actually applicable to ThrowRock itself, but just came over from Foresight Fight or some other game that I was working on where I happened to have something handy around. Anyway, so C programming language. It's a compiled language. Write a text file with instructions like this, pass it to a program called the compiler and the linker, then you get out a binary file called an executable, which you can double-click, and it runs as a program on your computer. Like this. Why is there no audio? I guess I had it turned off for some reason. Yeah, playing music was disabled. Anyway, so that's the very high-level basics. So anyway, the main entry point to my programs under STEM is target init, although that's not 100% true. It sort of is. This is what I think of as the starting point. There's a bunch of stuff that happens before this, and I'd like to actually go over that in detail. So when I double-click on this executable here, let's go over everything that happens between that double-click and being here on this screen, seeing this, hearing the music, etc. So before we actually get to target init, the real entry point is in the STEM framework. I have this thing I call a shell, which is a platform-independent API. Let's open this in a new window here. I don't do most of my programming on Windows, so I'm going to be a little bit slower navigating my file system here. Most of it these days is done on a Linux computer, which I don't normally use for recording. I could do it. I did it once for a Foresight Fight video, but that was a while ago, and I don't have it set up right now. 2014. Okay, that's how old this file is, at least. Not quite as old as I thought. Maybe this is less than a decade old, after all. Anyway, so this header file just sets out an interface for functions that I can call that will interface with system APIs on whatever platform I'm running on. So shell is the layer, in between my game code, which mostly doesn't care whether it's running on Windows or Linux or the Mac or a smartphone or on the web. In theory, in the future, I don't have my web platform quite set up yet. Someday. And I can just call functions like, what's a good example? Like shell get current time. That will reach out to whatever system time measurement API is available and give me the highest resolution measurement of time from some fixed reference point in seconds. That's the unit I use for all time measurements. So in the case of Windows, since we're going in depth in this example, I believe this calls query performance. Yeah, query performance counter is the Win32 API function, which gives me a high resolution CPU timer, and query performance frequency gives me the basically what units that's in. So I just get the current performance counter, divide it by the unit that it's made of, and that gives me seconds. Pretty simple on Windows. This might be more complicated or less complicated on different platforms, but like each platform I target gets an implementation of this function that talks to system APIs like these and returns something in a known format that I can use and just say, okay, I call that function, I get seconds. That way I don't have to worry about how it works on the inside. Anyway, yeah, so this is the main layer of glue. The shell is between the game code and the system APIs. There are some others that talk to system APIs, other STEM libraries that I have. I have it split up into a bunch of different ones. I went through these directories a second ago. There's a lot of them. Those are the names: 3D Model I/O, Audio Player, Audio Synth, Shell, Stem Object, WGL Shell. That's the Windows implementation of Shell. So yeah, it's a bunch of stuff. Names are sort of self-explanatory. If you are me, you'll know what they mean. If you're not, you might have to puzzle it out. Anyway, so shell, WGL shell specifically, I'll just use Windows as my example because most people use Windows. It's the most common one, but I have one of these for the Mac, one of these for Linux, etc. But yeah, Windows is just going to be the easiest example. Anyway, so the shell contains the actual main entry point of the program. So when I double click on an executable, the code that starts executing is here in WinMain. On other platforms, this will just be called main, but on Windows, they use WinMain for whatever reason. So, basically what needs to happen is a bunch of files need to be parsed and loaded that have to do with game data. I need to initialize audio output. So I'm saying these all out of order. Create a window, create an OpenGL context in it so that I can draw into it, initialize gamepads, set whatever configurations, do whatever game-specific setup that happens, that sort of stuff. So anyway, yeah, for every STEM application that uses shell, there are specific things that happen at startup that this function takes care of. Win32 is kind of verbose. There's a lot to that API, but it's pretty cooperative. I find that it tends to be a lot to write, but it'll usually do what I want without too much complaint. Each platform system APIs have a different feel and flavor to them. I don't mind the way Win32 is. It's pretty nice. So anyway, the first point of entry into game code is not actually target init. There's this other function that's called first. This is kind of some ugly preprocessor stuff. I've been thinking of cleaning this up so I can just have one single target configure function that gets called, but anyway, a function called target configure with some prefix is called and gets passed some arguments from the system, like, for example, command line parameters. So if I launched that executable from the command line and sent it some arguments, I think I can actually I can invoke it from here. So build, throw rock, build main app, debug, whatever, throw rock. Is this an argument I can use? Sorry, it's not no audio, it's disable audio, if I have that implemented. Yeah, okay, so here I just have a command line switch to turn off the audio subsystem. This was important for some kind of profiling purpose. I wanted to run my code without initializing the audio subsystem, and because that was getting in the way of a certain profiling program that I use. Not necessarily relevant for throw rock, but for other stuff, it just happened to come along because it was in my code. So anyway, that's an example of why this would be. Yeah, so that's passed in with these functions. Okay, but before that's actually passed in, again, let's go back to wglshell.c. The main thing that target configure is supposed to do is to receive a data structure here. Yeah, so struct wgl shell configuration, struct ns OpenGL shell configuration. A little detail about the C language in case you're used to other languages and don't know how this works. Star means pointer, address of, etc. This function receives a parameter which is a pointer to memory that lives in the calling function. I can't necessarily tell that by looking at this, but anyway, this is a pointer. When I modify this parameter, those modifications are readable by the calling function. So basically, I create a structure here. I pass it in as a pointer. I pass the address of it to this function. This can modify it and then return multiple pieces of data back to the caller, other than just the return value, which is void, so there is no return value from configure. It returns it in the structure. Anyway, so that's an out parameter. So it has that out parameter and also the input of command line arguments. And some extra stuff in case you want it from... Interesting, I wonder why I bring all this along. That feels unnecessary. That feels like I could get rid of it, but it's just there in case you really want Windows details in game code. There they are. Anyway, yeah, so I parse my command line arguments, which actually just looks for disable audio and nothing else. So iterates through them, compares to that string. If it finds it, it sets a variable that later doesn't initialize the audio subsystem. So that's pretty simple. That's the only command line argument. Right, I have these split up parts. Sorry, yeah, so these are preprocessor instructions. If you're running on a Mac, you get ns OpenGL target configure with these arguments and might need some specific things like, for example, ns OpenGL shell configuration has a boolean for whether there's a full screen menu item in the system menu bar when you start that up, but that's only applicable on a Mac. On Windows, that's not a thing you have to do, but use GL core profile, which is a specific way of setting up my OpenGL context. Anyway, and if this were running on a smartphone, which again, vestigial code here, this doesn't currently run on a smartphone. I've never compiled it for one, but in theory it could. Those don't receive command line arguments because there's no way to command line launch an application on a pocket computer, because that's just not how they work. Anyway, so on Windows, sorry, we haven't actually gotten to the call of this function yet. Oh yeah, this is definitely going to be a multi-part thing if I'm going over all this in detail. So where is, I guess it's not in this file, it's in this file. So this header file is the struct that gets passed in for configuring the application. Window position, window size, window title. So basically, WGL shell wants to call this configure function, receive all this information back of how should I initialize my application for you to, the game code that's using this shell to do its thing. So all that information is passed back. This is OpenGL specific stuff that I don't think I'm going to go into detail about. But if you know what it means, you know what it means. What icon should I use for the window? And yeah, so GL context setup stuff. Yeah, OpenGL implementation details, I think I don't really need to cover much. I'll just mention that, like, depth buffer would not be turned on for throw rock because it's a 2D application. I'm not drawing any geometry that's like in front of other geometry in 3D space. That's what a depth buffer is used. So for example, I would not enable this in the configuration function because I don't need to use it, so I don't need to allocate that and waste those GPU resources, etc. So that's the sort of thing I would set up here. So yeah, platform specific, wrapped in all these ugly preprocessor defines, then non-platform specific stuff that everybody does in configure, but is sort of specific to throw rock. Have I gotten to the invocation of that function yet? Not quite. Okay, so WGL shell sets a bunch of sensible defaults for every field of that struct. So your window starts at 20 pixels from the left side of the screen, 50 pixels from the top side of the screen. is 800 wide, 600 wide. You'll probably change all of these. This string, if you forget to change it, you being me, the person who's writing with shell, I don't expect anybody else to use stem. If I forget to change my window title in my configure function, it will tell me about it in the window. So I would get a window called change configuration arrow window title in WGL target configure. So that's what I'd see up in the actual title bar. But instead, I set it to throw rock, and that's the string I see here. I set it to throw rock somewhere. Or maybe it does... Wait, what am I looking at? So we got application name, stem human readable target name. That's the... There it is, all the way down here. Configuration window title equals stem human readable target name, which is a compile time constant passed in from my make file. So another thing about C, my invocation of compiler and linker, my compiler and linker invocations are managed by GNU make. I guess that G is silent, sorry, GNU make, which that is a system that I don't want to go into in detail, but basically this make file defines a bunch of stuff that gets handled by a global make file that interprets it and turns this into compiler invocations. One thing of which is this constant, throw rock here. This string eventually ends up as a compile time constant here. So this is the string throw rock. So basically when the compiler sees it, that's what it sees. Window title equals that string. So anyway, so I set some sensible defaults here and read the command line in the way Windows wants to do that. Then I actually call WGL target configure, passing in all these arguments, and then, right, so my game code can take over and do its thing. I call a shell function here to get the region of the screen where I could safely create a window. On Windows, for example, that would start all the way in the upper left corner and end in the lower right corner minus the taskbar. On a Mac, for example, that has a menu bar at the top, it would exclude that top portion. On some other system that might have some system UI on the left or the right, it would exclude that. Basically just like, what's the region of screen where I would want to create a window? Can I put this? Yeah, if I put it down there, it goes behind the taskbar. And, you know, on a Mac, it would exclude the dock, etc. So I want to know what that safe region is, and then I do some math to make my default window size as large as I can within that rectangle, while being an integer multiple of my internal resolution, which is defined by display width and display height. I think those are in globals.h. They are not. Are they at the top of main.c? They are not. Okay, where do I keep those variables? Are they in drawing.h? I don't have a drawing.h. I'm thinking of a different project. Shared definitions.h. There we go. I don't have any facility in this text editor for like going to a constant and asking it where that's defined. IDEs often have that. I don't use an IDE. I just use a text editor and a makefile and a command line. That's the way I like to do it. Anyway, yeah, so the pixel resolution is defined by tile size times number of tiles wide and high. So yeah, just multiply those numbers by 9 and you know the pixel resolution. And that is what I use to calculate the window rect at an integer multiple. Anyway, this is all code that I had already written for Foresight Fight. I just copied it over and changed these two constants, and it just pretty much worked. So this was not written newly. There's an extra bit of white space there. That's unacceptable. I wonder how that got there. All right, anyway. So yeah, it just centers that at the largest size it can with an integer multiple and sets the window title. And those are all of the configuration variables it sets up. It does one more thing and calls this register shell callbacks function, which specifies to shell. This is a pattern you might see in other Windows system API glue layers like, say, SDL or GLUT or whatever. So if you... Shell is basically my own version of SDL, Simple Direct Media Layer. If you want to do something like what I'm doing, I'd recommend just using SDL. If you don't need the customization, like, I don't know. I do my own for some reason because it gives me more control in a few ways that I care about. But anyway, the basic idea is I pass the addresses of functions that I want to call when a particular thing happens. So shell, in its inner workings, will know when a draw needs to happen. I specify a function pointer. So target draw is a function here in this file. There it is. Which I want to be called every time my my game needs to be drawn. Resized is whenever the window size changes, or I full screen and otherwise the drawable size changes. You know, user events like player presses a key, releases a key, changes key modifiers, etc. So all these things should be fairly clear. I don't think I respond to scroll wheels, so I could probably remove that. Again, lots of vestigial code from just because I copied from another application that might actually use scroll wheel events. If I were writing this entire thing, like this entire file from scratch, I wouldn't have extra stuff like that in it, but that would take more time, and I wrote this in a week, so I didn't have time for that. Right, when the application loses focus, regains focus. When I want to quit, yeah, this just always allows quit. So this function gives me a chance to say, like I clicked the window close button, but I didn't want that to actually happen because I have like unsaved changes in this productivity application. So do some work and cancel that and call quit later. Anyway. Right, and then there's another thing in here. This isn't a shell function, but I also have a separate UI toolkit for buttons and text fields and things. So this is the function that would call when something has updated and I might need to change my cursor. So same metaphor. A callback happens because a framework did something that I need to know about. This seems weird, but I think I understand why it is. Anyway, so I set up some callbacks. I have told shell how to call me when it wants to draw or when the user does something, basically. And then I return control to, right, this is showing in red because my open brace is repeated several times here in all the different platform thingies. Anyway, yeah, so text editor doesn't like it that way. So anyway, this returns control back to WGL shell. So after this has been called, my configuration struct is filled out with everything it needs to know. So now we're going to do a bunch of Windows API stuff to create a window and create an OpenGL context in it. On Windows, what you do first is you register a window class, which is, this is a Win32 structure that I have to fill out with all my own information. It owns its display context, I guess is what this means, and calls its resize function when I change its width or height. Something like that. Win32 is kind of arcane. There's a bunch of stuff in here that I don't like 100% understand, but I understand enough of it. This is an important thing. So just like here where I registered my callbacks to say when shell thinks I need to redraw, call this function in my code, which we'll go over at some point. Here, Win32 just uses a single callback function. So whenever a window does something, like I'm dragging this around and Sublime Text here, for example, needs to know, okay, so I moved the window over here, call some of my code in order to change it. So if I'm resizing the window, it needs to know to change that layout and redraw itself, etc. So window proc, we'll look at this in detail in a bit. But that just says, call this callback when something has happened that I need to know about. Unused fields. This is the application instance you're attached to. This is your icon that goes here. Just loads it from what's embedded in the executable, I think. So that's like makefile stuff. And apparently I have a problem. Does ThrowRock's icon show up on Windows? Let's actually run the release version 64-bit. It does not. I just get this default window icon. This is a framework problem that I need to debug. I don't know what's going wrong with it. For some reason, that icon doesn't show the way that I'm doing it. So something is wrong with this. In your own code, if you do this, The documentation says this is fine. If hicon sm is not set, it'll use hicon, but something's wrong with my icon resource or something. I don't know why that doesn't show up. It should. It did once, but something's wrong with this. Anyway. And the cursor that shows up when I'm inside the window is just the normal arrow. Doesn't have a background, doesn't have a menu. Its name is... This is not a human readable name. Why is this here? I guess this is just some internal identifier that Windows knows. This window class belongs to WGL shell. User never sees that. Anyway, so I register the class with Windows. Do some error checking just in case everything's completely wrong. I just call exit. That should probably be an abort call. Anyway, doesn't matter much. So then I get a window rectangle as Windows understands it in its coordinate system from what I set in my configuration. And that defines the content area of the window without its title bar. So basically, like everything from here to here would be what that rectangle is minus this part at the top. Yeah, just using Sublime Text's window as the reference here. So adjust window rect says like, so you tried to make that thing centered with this region, but it actually needs to be down a little bit to be centered properly with the top and bottom. So anyway, I think shell get safe window rect takes that into consideration. Sure, let's see how that get safe window rect. Let's see how that actually works. Oh man, it enumerates the connected displays. Okay, that's reasonable. And looks at their resolutions. Oh, this calls adjust window rect. Okay, yeah, so it calls the same function. Yeah, so anyway. Get work area. Yeah, work area is what Windows calls this region, minus the taskbar. Yeah, anyway, so you can sort of see how that works. So we were back down here somewhere. Interesting. Anyway, stirdupe. Okay, yeah, I know what that is. Anyway, so save the string that was passed into configuration's window title in a static variable in this file, I think. I need to know this in case I want to change the window title later. And then create a window with that title and location with this instance. So create shell window is a short little thing here that just calls Windows' create window function. So yeah. Oh, okay, so this is actually using the class name that was registered there. So that's how it's looked up. Okay, so this is a unique identifier in my application. I tell Windows I'm creating a WGL shell class window, which I had previously registered with register class X, apparently. With that title, with these features, with that rectangle. I don't know what these are. They're just nothing for this application instance. And then once again, just a quick little error check here. So that's created a window. I don't think it's visible yet, but that has created a window. Now, we need something to be able to put in that window, and it's going to be an OpenGL context. So we'll be drawing to the content area of the window using that graphics API. There are other options. There's DirectX on Windows. There's GDI if you want to just do like 2D drawing commands not using the GPU, but that's not the way I do it. So I guess this is this is kind of similar in metaphor to my whole call WGL shell configure in the game code to get the configuration variables needed for the application. So this sets up a similar structure for the OpenGL context. So here's all my defaults. Those are the struct field names. Don't worry too much about what's in those. Right, but if my configuration specifies it, I will double buffer. The color depth, alpha depth, depth, stencil depth, etc. is set to whatever I've specified in my configuration. And get the display context, whatever that is, and choose pixel format. So basically I say, these are the features I want what can you do, system and GPU? Like, what are you capable of? So I choose the pixel format. I say for this display context, that's the pixel format, the one that I chose based on these parameters that I want to use. And then I create my GL context. So then I have a, what type is this? HGLRC. Okay, that's what it is. So WGL create context. WGL is the glue layer on Windows for OpenGL calls, basically how you call it and connect it to a Windows window. It would be GLX on Linux, NS OpenGL, or CGL or AGL if you're a long time ago on the Mac, EGL for Android, EAGL for iPhone OS, and I think you just go straight to SDL for mscript, and if you're building for the web. I haven't gotten that far yet. But anyway, so WGL shell is what we do here. Create a GL context, make it the current context, error checking, standard stuff, you know. And now I need to know about some extensions. Let's see, because there are a lot of different versions of OpenGL, but an executable can run on a pretty wide range of versions of Windows. Like something that was built for Windows XP could still run here on Windows 10 that I'm running now. In some cases, vice versa is also true. I mean, at the very least, this application I built on Windows 10 certainly runs on Windows 7. I don't think I tested it much farther back than that. I am using some fairly modern OpenGL features. Fairly modern, I say. OpenGL 3.2 is pretty old, but, you know, it doesn't go back forever, not to like every computer with dedicated graphics hardware. But anyway, what am I actually doing here? This is just all part of context setup. I'm just specifying to OpenGL what I want. We're drawing to a window. This is an OpenGL context. I don't know why you have to specify that. If I'm using WGL, what else would I use? If this is specified in the configuration, and it is for ThrowRock, then I want this to be an OpenGL 3.2 core context, core profile. If we're double buffering, I want a double buffered context. These are the depths I want in my color buffers and other things, etc. If I want multi-sample, this is how I want it. Yeah, just a bunch of boilerplate, basically, to say how I want to interface with the GPU. So if all of that has gone well, I destroy the window and create a new one. Oh, yeah. WGL is weird. I create a dummy window here just to get access to, like, choose pixel format or something? Yeah, I think that's how it is. I got to create a window, call choose pixel format on it, throw away that window, then create a new one with the real configuration I want. That's right, I'd forgotten about this detail. Yeah, it's silly, kind of roundabout, but anyway, that's what it takes to initialize a WGL context the way I want to. Anyway, yeah, so we create the window again, and set its pixel format to the previously chosen one. Create another GL context. That seems so unnecessary, but for some reason it's necessary. Make that the current context. I guess if you can't get extensions, then there's no way this is going to run. ARB pixel format. Okay, this is just like an extended way of setting up the context. Like I get some default thing, but then I can specify more options if I have this extension, which I will on every bit of hardware this program can actually run on. But anyway, it's there. That's how it is. If I want vsync, that is an option that I can set in target configure if I want to. Vsync, for those who don't know the technical details, means that after I have finished telling the GPU how I want to draw a frame, like I've specified, oh, this geometry is here, and it's constructed it, what vsync does is it holds onto those drawing commands and waits until the display, which refreshes at normally 60 hertz or more, is at a vertical blank interval. So basically, like, at a quantized 60th of a second or whatever your refresh rate is, it will then present the newly drawn window contents or OpenGL context contents, however it's being presented. And VSync just waits for that blank interval for that to happen. So that's why you get an entire image drawn all at once when VSync is on without any so tearing is when you get the top half of a new frame because it's still being copied while the monitor is redrawing. Actually, you get the top half of the old frame and the bottom half of a new one. So yeah, for example, your display is in the middle of redrawing. It redraws from upper left to lower right in reading order, basically. And the electron beam, if you're on a CRT, for example, is right here at this position. That position bisects the window of your game content. So it's already, drawn the previous content of the window. So it's scanned across to here, and then it's right here, and you say, basically you do a little buffer swap to say, instead of reading from the buffer of pixels that you were reading from for my window contents, go read from this one instead. And it's okay, electron beam is here, continues scanning, and now it's reading from a different picture. So it drew half of one picture and then started drawing a different picture from the bottom, just because the timing happened to work out when my drawing finished, that it was in the middle of repainting itself when that happened. So that's why screen tearing is a thing. You get the top half of one image, the bottom half of another. VSync solves that problem by making sure that the electron beam on a CRT or the scan line on a LCD. I don't know what you actually call that for an LCD, but anyway, whatever. The draw position is out of range of visible stuff. It's at a vertical blank, as they call it. Nothing is being drawn vertically before it actually does the graphics swap. So you get the entire picture all at once. So that's how VSync works, but it involves a delay and can cause input delays to happen. You'd think it wouldn't. You'd think those would be always less than a 60th of a second, but just implementation details mean that sometimes it causes input delay because your key press isn't processed until a couple of iterations of vertical blank later. So it's something you don't necessarily always want. It can introduce latency. It's complicated. It's complicated enough that I just want the option of sometimes having it on and sometimes having it off for different situations. So Shell can do it either way. Can have it on, can have it off. Sorry, what did that command actually do? Calls a WGL function if the extension is available, because you can't always call WGL swap interval ext if it doesn't exist on really old graphics hardware. There's this whole dynamic load thing here. Basically, this works differently on different operating systems. On a Mac, if you compile a GL link against lib OpenGL or whatever it's called, you just get a normal function you can call, just for example, GL get string. That gets linked in. I can just call it like a normal function. But on Windows and Linux, for example, for some reason, you have to load function pointers yourself from a dynamic library at runtime. So I'm saying if in the extensions string, stir searches for a string and a string. That's a C library function to do that. If the extension string contains WGL ext swap control, that means I can load this function pointer, which has a function signature that's defined somewhere, which then I can call that function pointer to specify whether VSync should be on or not, and that's where I call that. Anyway, it's kind of roundabout. This is going to be important later because I have to load lots of OpenGL functions like that. Anyway, so set VSync to whatever it's set to at startup. Then I finally get to show the window that I created. Window is shown, and if something has happened in that process that has changed the size of the window, there's some reason this can happen. I forget what it is. No, that's not exactly how it is. Well, anyway, it's complicated. If something has happened in that process that has changed the size of this window, or if otherwise the game code needs to know about a window size change, then I call the resize callback. This is what was established in register shell callbacks. So shell resize func sets target resized as the function to call right here and every other time the window size changes. So I pass in what the current window width and height is, and the time at which this was called. Let's look at what resized does. So this just records what the current width and height of the window are, what its aspect ratio is, what the scale factor of the display is, because this program can run on high DPI monitors, not on Windows. I don't have any Windows support for this yet, but on a Mac or on Linux, if your display has 2x2 pixels per point, like if your actual resolution is 3840 by 2160, but your logical resolution is 1920 by 1080, this knows how to handle that. So that's a scale factor of 2. I really need to do the Windows support for that. I just have not yet. And yeah, then this just passes us on to whatever it needs to know downstream of here. We'll get to that later. And so there's this weird thing. This is an actual OBS recording concession. Add exit is a C function you can call to have, when your program exits cleanly, to have a callback called. I found that it was necessary to actually explicitly destroy my WGL context when my application exited cleanly if OBS was attached to it. This might not be true in current versions of OBS. This was added a long time ago, but my program would actually appear to crash on exit if I didn't do this, if OBS was attached to it. It does something with the way it hooks into the OpenGL so that it can capture the image and record it and stuff. So anyway, that was an interesting little implementation detail. As a general principle, I do not free memory or destroy anything that was allocated during the lifetime of an application when it exits, because all of those resources are automatically reclaimed by the system, and all you do by actually calling the free function or WGL delete context, unless you have a very specific reason to do it, is just waste CPU time. Because basically you're just freeing memory that's going to be freed anyway by the system, and the system's going to do it a lot quicker and more efficiently than you. So basically, like, a lot of things just don't ever get freed. Just the system does it, and it does it better than I could do it. So this is a rare case of when the application exits cleanly, I want to actually explicitly destroy something, but that is unusual. Anyway, yeah, so now shell itself knows that it's initialized. I actually call target init, which is what I consider my main entry point here. And this function normally never returns, but if it does, like if I don't call shell main loop from there, like if this happens to be an application that uses shell just to do a little bit of operation and then return right away, then that'll just return to the operating system. So this would exit the executable, but this never executes. Anyway, so sure, let's make that episode 1 of the programming in-depth of this. Next time, we'll get to what the game code actually does once the operating system has initialized its window in GL contexts. So hopefully this is informative. I don't know, maybe this is too in-depth, but maybe some of you will find it interesting. I kind of have a little bit of an evangelism thing going on here. I would like more applications to be written with a full understanding of what goes on in the system APIs and things. And I'd just like to show here that, it's not this completely impossible, mystical thing. You can do it. Any programmer can write code that directly talks to system APIs and have an executable that is a very, very real thing. And boy, what am I trying to say? It's not necessary to use something like Unity or whatever just to write any game. You can do it a bit more raw, just talking directly to the system, and it works super totally fine. It's accessible. For some reason, I want more applications to be written like that, because that's the way I like to do it, and I think it's cool. Anyway, so we'll get to how the game initializes itself next episode, I guess, and then move on from there.